Hummingbirds have to be small and light in order to be able to hover to sip flower nectar, but having to be so small also means that they can't store very much fat. So when a hummingbird doesn't have enough fat to survive the night, it goes into torpor, which is an energy-saving state where they lower their heart rate, breathing rate, and body temperature, and save up to 90% of the energy that they would use otherwise if they were just sleeping at a normal high body temperature.
You may have heard of torpor before. Hibernation, like what bears use, is also a form of torpor. Hibernation is a special kind of torpor that lasts for a very long time, like weeks or months or whole winters. But there are lots of other animals, like hummingbirds, bats, and a lot of rodents, that can use torpor for just a short period, like to save energy overnight. Here is a thermal video of a hummingbird asleep at a high body temperature. And this is a video of a hummingbird in torpor. You can see that it gets almost as cold as the outside air. It's barely breathing. Its heart rate has slowed down from 600 beats a minute to less than 50 beats a minute. And like Sophia said earlier, it's saving a bunch of energy.
Torpor is controlled by the brain. Different parts of the brain regulate when the animal enters torpor, how cold it gets during torpor, and when it warms back up. All previous research on how the brain controls torpor has been done on mammals, like bats and rodents. So my project is the first study to look at how the brain controls torpor in birds, which is really exciting. My project specifically focuses on which genes are involved in torpor in different parts of the brain compared with normal sleep. We want to figure out how hummingbirds are able to survive getting so cold, barely breathing, hearts barely beating, and then how they can just wake up in the morning and fly away. What we found is that most genes involved in torpor in the brain have to do with the body's biological clock, which makes sense because it's super important that the bird knows when to warm back up. We also found that the brain is doing fewer things related to heat and energy production and visual function in torpor, which makes sense because it's not producing heat and it doesn't have to process any visual input while it's in torpor.
This research has lots of useful applications, mostly relating to medicine and human health, like for stroke and cardiac patients. Some torpor researchers are working on safely cooling humans to perform surgeries at colder temperatures to decrease damage to tissues. And my personal favorite, what if we could learn how animals use torpor and then put humans in safe torpor for space travel? If they use torpor, they need less oxygen and food, and spacecrafts would be lighter and can go way further. Wouldn't that be cool? Cool, get it?